about different compounds like ionic and covalent metallic, and hopefully by now you've done the Nearpod on that. But more importantly, I hope you have done the homework that you had writing the formulas. And one of the things I wanted you to get out of that homework was the patterns that form whenever you have metal and nonmetal compounds being joined together. So let's just do a real quick sketch here. This represents our periodic table. There's our valley. And I'm interested in just column 1 and column 2 for the moment. Any element in common 1 has one valence electron, and everybody in column 2 has two valence electrons. And then you come on over here and you have 13, 14, 15, 16, and 17, and there's 18 right there. And we said for column 13, this was 3 valence electrons, this was 4 valence electrons, then 5, 6, 7, until we got to 8. And this is our full outer shell. That represents basically what the octet rule is all about. Okay. So we're not interested in column 18 right now. We're going to ignore column 18. We're only interested in column 1, column 2, then 13, 14, 15, 16, 17. And you'll remember from previous videos and also in class, I've said that if you have column 1, these are metals and they like to lose electrons. So when they lose their valence electron, then they become a +1 ion, also called a cation. And if you have a column 2, they will lose their 2 electrons and become +2 cations. And this is fixed. It can't be any other way than this. And we call that, because of that, we call 1 and 2 and then 13 through 7, we call them representative. Representative means that they will always work this way. And then we get to column 3, and for at least the metals, column 3, or at least for aluminum I should say, aluminum and boron for sure, these will form +3 ions. And then when we got to group 4, this could go either way, so we said plus or -4. But when we got to 5, we are now in the nonmetal zone. And for just the nonmetals, not the metals underneath, but for the nonmetals, column 5 is already at 5. It needs 3 electrons, so it will gain, and it will gain 3, and that will give it a -3 charge. In column 16, it's going to gain 2 electrons, so that's -2. And in column 7, it's going to gain 1 electron. And the whole purpose of this is for the octet rule. The octet rule simply says atoms must have full outer, and I can never remember if that's 1T or 2. I don't, because 2 T's would be otter, so this would be outer shells. And then in most cases for the representatives, that means 8 electrons, with the exception of hydrogen and helium, which will have 2 electrons. Alright, and so as you were making your different formulas, I gave you the elements, I gave you how many particles you needed, and you got practice writing formulas. But the pattern I wanted you to see was that if you have a group 1, and I'm going to start calling them groups instead of columns. If you have a group 1 and a group 7A or 17, these relationships were 1 to 1. And if you had a group 1 with a group 16, that relationship was, in this particular case, this was going to be, you would need uh, two, you would need two of those to one group 16. And if you had a group 1 to a group 15, this one would be 3 to 1, like that. And if we can go the opposite direction. If we had a group 1, let's say, well, let's go this way. Let's go group 2 to group 17. This would be 1 to 2, and group 2 to group 16 was a 1 to 1, and then group 2 to group 15, in this particular case, this was going to be a 3 to 2. And you're saying, Dr. Hopkins, how do we know that? Well, number one, if you did the homework, you saw this was starting to happen when you arranged the compounds you made on the page 1 into your periodic table. Now let's explore exactly what is going on here. In the first case, anything out of group 1 is going to be plus 1. Anything out of group 17 is going to be minus 1. And sorry, not 2. Minus 1. And what happens is this is electrically neutral because they cancel each other out. If we look at group 1 to group 16, again, you have a atom that's got a charge of minus 2, so you needed 2 plus 1s in order to balance that out. And in group 15's case, that's a minus 3, so you needed 3 plus 1s to balance it out. Over here, again, we have plus 1, not plus 1, plus 2, because this is group 2, and you needed to have at least 2 negative 1s to balance it out. And then over here, we had a plus 2 and a minus 2, so that balances out. And then you had, sorry, let me get, realize I was off camera, sorry. And then you had a plus, let's see, you had to have 3 plus 2s to balance against 2 negative 3s. And that's as big as it gets. Anything greater than a 2 to 3 ratio or a 3 to 2 ratio, and you're done. So all of these relationships have to do with electrical charge, and that what we said was neutral. Neutral is balance of charge. You have to balance them. Now, fortunately for you, because of that, we can exploit that when writing compounds. So let's take an example. Let's take calcium chloride. And we start by writing the symbol down for the first name, so that's Ca. And the symbol for the second one is Cl. And calcium comes out of group 2, so it's going to have a plus 2 charge. Chlorine has a minus 1 charge, and I'm going to do something called crisscross, not the rap stars. Crisscross means I circle the number portion and I bring it down to the opposite symbol, like that. And then those become my subscript. So now it's going to be CA, 1 is understood, Cl sub 2. Let's try it again for, in this case, magnesium oxide. Both of these have a charge of 2 of some sort. Magnesium is going to be plus 2. Oxygen will always be minus 2. So once again, I'm going to circle just the number part and bring it down. Leave the charges up there. Charges don't go to the bottom. And when I rewrite this, it becomes Mg2O2, but right away you should spot not empirical. Remember, ionic compounds have to be empirical. Empirical, there we go. And so I would have to reduce it down to MgO. So that's what we mean by crisscross. Now the other thing I wanted to bring up with you is naming. The metal is always written first, and you just write it like it is. And then the non-metal, get back on camera, non-metal is written second with an IDE suffix. Now the reason we do that, it finishes the name. I want you to think of it as a married name. If you want, not to be sexist, but if you want to think of the metal as the male and the non-metal as the female, and the female's taking the male's last name, but they're going to change it to IDE. So look what the difference is. Let's take sodium chloride, for example. The married name is going to be sodium. You write the metal name out. And then chloride, but we're going to change that, instead of chlorine, INE, we're going to change it to IDE, as opposed to sodium chlorine. Now, this is where the reader hears and reads out loud sodium chlorine. It sounds like two different elements. But the moment the reader reads chloride, we understand now that this is a joined couple. This is a cation and an anion that have been brought together. Generally, when we talk about the metal cation, we just say sodium ion or magnesium ion. When we talk about the anion, we call it by the IDE ending, so fluoride, chloride, oxide, selenide for selenium, phosphide. So those IDE endings. And it's important to understand this IDE ending is for what we call monoatomic anions. This is very important to remember. Mono means one, atomic means atom. And since we're talking anions, we know this is charge. The reason I bring that up is because we're going to get into polyatomics in the next video. Now, I have a lot of things on Canvas for you to look at. Do not ignore them. There is help. There's some more videos, professional videos. There are cheat sheets up there, especially about the cations and especially the polyatomic cheat sheets. Make sure you download those, get them on Google Drive and look at them there, or you can print them and have them with you. You're going to need p-table. Expect to be using p-table a lot here as we go through and learn our different compounds. All right, guys, that should hold you over Tuesday. And I want you to do the naming and writing ionic compound sheet that I've posted. That is your homework. And if you have any questions, just give me a shout out in email. If we're back at 50% on Thursday and Friday, then I will do my best to answer questions that you have. I do want to start covalent bonding though by Wednesday. So be prepared. You got Tuesday sort of off. It's voting day, but I would use that time to get caught up on your homework and get caught up in class, okay? All right, guys, have a good one, and I will be talking with you soon.